All right, so these next couple videos are about section 3 and chapter 7 for chemistry. So we're going to go through some examples of how to calculate formula mass and molar mass and how to use those to convert back and forth from grams and moles. And then we're also going to talk about percent composition of a given chemical compound. So formula mass, first and foremost, it's the sum of average atomic masses for all elements represented in a formula, right? That average atomic mass is found on your periodic table. So just as an example, some examples, hydrogen is 1.01, carbon is 12.01, right? Nitrogen is 14.01, oxygen is 16.00, sodium is 22.99, right? I'm just throwing out a couple of examples there that I actually know off the top of my head because I've looked those up so many times that I can't not know them, right? Otherwise, there's a lot of elements that I don't know the mass for. If you asked me what the mass of bromine is, I'd have to look it up because I don't know it. I haven't had to know it for any reason. But otherwise, formula mass and molar mass, right? The difference being formula mass is for one molecule formula unit, and molar mass is for a whole mole of a compound, right? Basically, the units are the only thing different, right? Formula mass is in AMU, molar mass is in grams. So if I look at this example that's in your notes, right? I had to grab that paper real quick. So you had that 18.02 AMU per atom, and then you're multiplying it times Avogadro's number, which is atoms per mole. And then you have a conversion factor for grams in AMU. So basically you multiply 18.02 times 6.0222 times 1.661, and you're going to get an answer of 180.2 times 10, and again, our rules for powers of 10, I just add when I multiply, right? So 23 plus a negative 24 is actually a negative 1. And then I'm going to make an adjustment here because I don't want scientific notation for this. Excuse me. If I add 1, I can get back to 0, but that means I need to move the decimal to the left, and that means that my answer is 18.02 grams per mole because all those units cancel out. And all I was trying to do there is demonstrate and illustrate that one molecule of water has a mass of 18.02 AMU, and 1 mole of water also has a mass of 18.02, but it's grams instead of AMU. So they have the exact same number, it's just different units, right? So when I talk about formula mass or molar mass, really it's the same thing. You're going to calculate them the same way, right? But again, the new trick, right, we actually used these before, is that now I have compounds like sodium hydroxide, and I have to add up those pieces, right? And again, this is why I know some of these things over here. I know that sodium's 22.99, and I know that hydrogen's 1.01, and I know that oxygen is a 16, so when I add those things together, I get exactly 40. So not only do I know all those masses, but I also remember that sodium hydroxide has a mass, a molar mass of 40 grams per mole because I use that substance so often in the lab. I have to make concentrated sodium hydroxide solutions all the time for different purposes, right? So I need to know what the molar mass is in order to do it. But it's just adding up pieces. The hardest part of most of these problems is I tell you it's ammonium carbonate and I don't tell you what the formula is. So again, for those of you that have been doing well this chapter so far, it may or may not be easy for you to come up with this formula for ammonium carbonate. But from there, that's just the first step. But if you get this step wrong, everything ends up wrong after this because there's really nothing you can do correctly from this point. Because you need to know that there are 2 nitrogens to multiply that 14.01 times 2. Again, just get that number off your periodic table. You need to know that there are 8 hydrogens, because 2 times 4 is 8, and each one of those is 1.01, you need to know that there's 12.01 grams for carbon. You need to know that oxygen's 16 and that there are 3 of those, so that you can get a total mass here of, let me check that real quick, 96.11, so that you can actually do the problem, because this isn't even the problem yet. The problem actually asks you to change 2.5 moles of said substance into grams. So I need to multiply by this 96.11. But I'm not just going to give you that molar mass directly. I'm not just going to tell you that 96.11. You have to figure it out from scratch. You have to come up with a formula. You have to add up the pieces. You have to be able to do all of those steps to get this answer. Now, multiplying here, I happen to get an answer of 240.275. I'm going to round it to 2 sig figs because I have to use sig figs. And I'm going to get 240 grams, exactly 240. Not sure where that little dot came from. The pen's kind of being crazy. So it's not 2.4, it's 240. But that's my mass of the ammonium carbonate. I just put a label on it. And then we're good. Right? So that's one problem. This next one, iron sulfate, ferric sulfate. Maybe you can, maybe you can't. Just make this formula off the top of your head. If you can't, though, you're going to have to find that information and make sure that you put these things together in the right ratio, right? Because I'm going to need to add up 2 irons, which happen to be 55.85 on your periodic table. I need 3 sulfurs, because this 3 applies to both the sulfur and the oxygen. So I'm going to need 3 times 32.07, I believe it is. And then I'm going to need 12 oxygens, because 3 times 4 is 12. And add all that up, I'm going to get a pretty big mass. This time it's going to be 399 point, let's see, it's 91 grams. And then I'm going to use that answer to do the actual problem, right? Because I need to change 3.1 moles into grams. But if I don't know that there are 399.91 grams in a mole, it's kind of hard for me to do that. So again, I just multiply, I get some kind of answer. I'm pretty sure with sig figs and everything else, I'm only going to get 2 sig figs, so 3 times 400 is about 1200. So I'm pretty sure that's going to be my answer. Grams of that iron sulfate, putting a label on it. And remember, it is ferric sulfate, so there's a +3 charge, not a +2, which is why I needed a 2-to-3 ratio to begin with. If it was normal, if it was ferrous sulfate, then I'd only have 1 of each of those ions. Finally, right, one more example for this video. This one's a little bit easier, but also another detail, right? This time I told you the formula. Awesome, right? So you add up those pieces and do what you got to do. Now, 9 times 12.01 plus 8 times 1.01 plus 4 times 16.00. Add all those things together. I'm going to get a mass of 180.17 grams, right? I'm going to use that in this problem, but there's also another little trick here. I need grams, not milligrams, so I might need to move my decimal over. So I'm going to start with 0.1000 grams of my aspirin. This is my mass that I want to change in the problem into moles, because 1 mole is 180.17. I can flip-flop that fraction however I need it to be. But there's actually one more step here, because it actually asks me how many molecules of aspirin there are. So going back to that problem we did with water in the notes, remember there's 6.022 times 10 to the 23rd of anything in a mole. So I can put molecules here, put mole underneath. Everything's canceling except for that molecules, and I can come up with an answer. So it turns out I get an answer of 0.00334 times 10 to the 23rd. So I just multiplied those two numbers, divide by 180.17, and then tack on that times 10 to the 23rd. I will need to make an adjustment there because I got to move the decimal where it's supposed to be. And that actually tells me to subtract 3 if I move to the right. So my final answer would be 3.34 times 10 to the 20th molecules. Couldn't figure out if I was making a C or a U there, but there we go.